All right, so it says the return trip was 284 miles shorter than the first part of the trip. So it actually might be better if we let the variable be the first part of the trip. So let's say the first part of the trip we'll call F. And if the first part of the trip is F, then the return trip is going to be 284 miles shorter than the first part. So that's going to be F minus 284, right? So we've got the first part of the trip is however many miles long, we'll call it F. And then the return trip is going to be F minus 284. And then it tells us that the total distance is 1,356. And a total means we're doing what operation? Adding, right? So we're going to add the first part of the trip, which is F, plus the return trip, which is F minus 284. And that should give us our total, which is 1,356. Right? Now, before we solve this, though, we need to do what? Combine like terms. Here I have 1F and 1F. So that gives me 2F minus 284 equals 1,356. So now to solve, I need to do what? Add first. So plus 284 on both sides. So then I get 2F equals, and someone was 1,356 plus 284. Someone to calculate it real quick. $1,640. And then our final step is divide by 2. So we get F equals, and 1,640 divided by 2 is 820, right? 1,640 divided by 2? Okay, F is 820. Is that the answer to the question? No, because the question isn't, because remember, F is the first part of the trip. And the question asks us, what is the distance of the return trip? So if you got 820 as your answer, then that means you wrote your equation right, you solved your equation right, you just didn't pay attention to making sure you were answering the correct question. They want to know the return trip, which is 820 minus 284. So if you do 820 minus 284, what do you get? Someone with a calculator? 820 minus 284. Huh? 536. And is that the correct answer? Yeah. So, with word problems, always make sure you're careful that you're answering the correct question. Because 820 is the correct value for F, or whatever variable you use, but it's not the answer to the question, because the question was the return trip, not the original trip. All right, Hannah? Number 5. So number 5, we have a car wash. And it says, during the spring car wash, the activity club washed 14 fewer cars than during the summer car wash. They washed a total of 96 cars during both car washes. How many cars did they wash during the spring car wash? So once again, we have one expressed compared to the other. It says, the spring car wash, they washed 14 fewer than during the summer. So I'm going to start with my variable being the summer car wash. So if I let, M be the summer car wash. Then the spring car wash is going to be M minus 14, right? Because it said we washed 14 fewer during the spring than during the summer, right? And then once again, it tells us the total. They washed a total. So total tells me I'm going to do what? Add. Total is an addition word. The total of cars is how many of the cars they washed in the spring plus how many they washed in the summer. So in the summer they washed M. In the spring they washed M minus 14. And if I add those two amounts together, then that should give me 96 total cars. Now, if we combine our like terms, which we'll need to do before we solve, what do we get? Well, we have 1M and 1M, so that gives us 2M minus 14 should equal 96. So from there, what do I need to do? Add 14. So then I get 2M, and 96 plus 14 is 110. Divide by 2 on both sides. M equals 55. Is that the answer to the question? Because the question says, how many cars did they wash during the spring? And M is the summer, right? M is the summer car wash. We want to know the spring, so we need to know the summer amount minus 14. So $55 minus 14 gives us 41. So 41 is the number of cars they washed during the spring. So again, it's that issue of if you got 55 as your answer, then you probably wrote your equation correctly and solved it correctly, but you just didn't make sure you were answering the correct question at the end. So always make sure you read the question and know what you're answering. All right, Brush. You did what now?
Adding 14 to negative 14, I subtracted.
What did you do on this side?
Subtract.
And what did you get down on this next?
82. I divided that by 2.
Oh, you know what you probably did? Was your equation to M minus 14?
Those two as minus 14.
Because you could have possibly, if you set up your equation differently, like I set M to be the summer car wash and M minus 14 to be the spring, and you could have set up, like if I made this the spring car wash, well, if during the spring they washed 14 less than during the summer, then the number of ones they washed during the summer would be M plus 14. So then you would have had this same expression, except it would be 2M plus 14. So basically what you did is you solved, did you get 41 as your answer when you solved for M?
It's the exact same equation, but I like subtracted 14.
Now we're just going to show
Right, but I'm saying, did you get 41 as your variable? Did your variable equal 41 or 55?
41.
Okay, see what you did was solving it that way is like saying, okay, if I had set it up differently, where if I had set the variable to be the spring one, then the summer one, since the spring they washed less, then the summer would be plus 14. And then that in that case, subtracting 14. So basically, yours is still wrong because according to what you set your variable up to be, you set M up to be the spring car wash. And in the the summer car wash. And in the summer, they didn't wash 41, they washed 55. So if you pay attention to your variables, it's still incorrect. And you can't just do subtraction, you have to do the opposite operation. The reason that you still got the same numbers was because depending on whether you set your variable up to be spring or summer, it would be the same equation, just one would be minus 14 and one would be plus 14. That's why you got the same numbers, but it would still be incorrect just because you're telling me that the summer car wash, they washed 41 and the spring would be 55 instead of 41 in the spring and 55 in the summer. Does that make sense? Okay. Olivia?
Why would you cross out, why would you do 55 minus 14? Because then you already cross out 14.
All right, so number 13. All right, so video games. It says 3 friends share the cost of renting a game system. Each person also rents one game for $8.50. If each person pays $13.25, what is the cost of renting the system? So this one's a little bit different. Almost all the other ones have been, totaling. We're just adding things together. This one's a little different, though. Now think about it. If you are one of the people that is renting this game system, just one person, what is going to be your cost for renting the system? What are you actually going to have to pay? Laura? Okay. Not a third of the total cost only, though. You're going to need to rent, if we let X be the cost of renting the system. So X is the cost of renting the system, okay? Well, you're going to pay 1/3 of that, right? Because each of these 3 friends are sharing the cost of renting the system equally, right? So X divided by 3 would be one person's share of the cost, right? But is all you have to pay is 1/3 of the system? No. You also have to pay $8.50 because each person is going to rent one game. So the cost of the system divided by 3 is what you have to pay for the system. But in addition, you also have to pay. So you're going to add to whatever you pay for that third of the system, you're going to add the $8.50 that you pay for the game that you rent. And then it says that each person pays $13.25. So each person spending whatever a third of the cost of the game system is, plus the $8.50 that they have for their game, each person is going to pay $13.25. Now, really, you're just writing the equation for one person because everyone's doing exactly the same thing, right? So one person pays the cost of the system divided by 3 plus the $8.50 for a game. So does everyone follow the logic on that one? Okay? So then, to solve this, it's just like the other ones. Now, this one, we don't have any like terms to combine. So to solve, we just start by subtracting the $8.50. So then I get the price of the system divided by 3 equals, and then let's see, $13.25 minus $8.50. 13 minus 8 is 5, so $4.75. Is that what y'all got? $4.75. 13.25 minus 8.50. Okay. Guys, when I ask you to check my math, I really mean it. Sometimes I make mistakes when I do math in my head, so don't just nod along. Like, what's the question?
I got 575.
Okay. I think it will be 4.75. What'd you say?
Well, I probably just had it wrong. But it's 475.
Okay. Huh? Well, we're not done yet. This is x divided by 3. Sorry, yeah, this is x divided by 3. We still haven't solved for x, so now our second step, I'm just trying to make sure I'm doing the math right before I get to my final answer. So So from here, now I need to multiply by 3 on both sides. Now here, if my answer doesn't match the books, now we have a problem, but hopefully at this point. So let's see, 475 times 3, let's see, 12 plus another, is that right, 14.25? All right, so $14.25. So X is $14.25. Is that the answer to the question this time? Yes, because this time the question is, how much does the system cost? And X is the cost of the system. So this time when we found X, we have actually found our answer. But always make sure you double check that you know that you're answering the actual question they're asking. All right. Let's see. Let me do this. We have a practice test